everyone. Today we are going to be performing face recognition using computer vision. This is a beginner-friendly project and just needs basic to intermediate Python knowledge as a prerequisite. So let's get started. First of all, what exactly is computer vision? Computer vision is a field of artificial intelligence that trains computers to interpret and understand the visual world. It enables a computer to see, identify and process images in the same way that human vision does and then provide appropriate output. So what we are going to do in this project is count the number of people entering a room. It distinctly counts the number of people, which means that a person leaving the room and re-entering would not be counted twice. This is helpful in keeping a track of the number of people using the resources of a lab per day and later on analyzing the requirements based on the data. It can also be used for attendance verification. The libraries I have used for this are mainly OpenCV, which is an open source library used for real-time computer vision. Face recognition, which is used to recognize and manipulate faces and facial features in Python, and DateTime library, which is used to manipulate dates and times. So let's get started with the approach that we have used. First off, we start by detecting the face. For that, we use a cascade classifier object using har cascade. A cascade classifier is a kind of classifier that consists of several simple classifiers or stages that are applied to a region of interest until at some stage the candidate is rejected or all the stages are passed. By this, I mean that the classifier detects a face in several stages by marking the area where it thinks it has found a face. Finally, the area is passed if it's a face and rejected if it isn't. A har cascade is an approach where a lot of positive and negative images are used to train the classifier. Now let's see a small clip to understand how this works. The black and white images are the har-like features that are being used to detect if a face has been found. As you can see, the classifier has marked the area where it thinks it has found a face. So this keeps on repeating until the marked area is rejected or passed. In the end, the face is detected. After that, the DetectMultiscale function is used to detect objects in the frame, which is a face in this case. Then it is converted into a face encoding. A face encoding is a 128-dimensional vector that quantifies the features of a face. That means that the features of a face can be represented by a 128-dimensional vector. We then store the face encodings in a list, which can be used to compare whether the encoding of a person already exists or not. If it does, then that means that the person has already entered the room on the same day. Finally, the length of the list will give us the number of distinct people entering the room. So let's get started with the code now. Okay. So first of all, I have imported the OpenCV library. Then I have imported the DateTime library, then the face recognition library, and then the OS module. So let's get started now. I have initialized the camera using the video capture function of OpenCV library. The 0 here indicates that the built-in camera is being used. The date of today is being stored in the dt variable. Then we have created a cascade classifier object using the cascade classifier function. The argument passed into it is the path to the har cascade. For this, we need to download the har cascade. The links for the same would be provided in the description below. Then we initialize an empty list which would store the faces that are detected from the camera. We have NOF, which denotes the number of frames, and a list called as face list is initialized, which would store each face's encodings. So now that we have initialized everything, let's start. We know that a video is a series of image frames. So we use a while loop for every image frame that is being captured. So in this while loop, first of all, we store the date for today in a variable called as now. Now if the dt date that we stored earlier on is greater than now, then that means that a new day has started, which means that we need to empty face list, which was a list of encodings of the people that had entered on a day. So since a new day has started, we need to reinitialize it, and count would be a variable which stores the count of people that have entered the room in the particular day. After that, we would invoke the read function, which returns check and frame. Check is a bool which returns true if the current frame is successfully captured, and frame returns the image as a numpy array. Then we convert the image that is detected into grayscale. This is done because it is easier to detect faces in a grayscale image. So the arguments provided to it are the current frame and the function to convert it into a grayscale image. Then, as I specified before, we use the DetectMultiscale function. This is used to detect multiple faces in the image, and it returns a list of the faces in the current frame. Since we have initialized faces as an empty list, hence it is stored in faces. The arguments for it are, first of all, scale factor, which is 1.5 here. Scale factor is a parameter specifying how much the image size is reduced at each image scale. And 5 here denotes the min neighbors, which is a parameter specifying how many neighbors each candidate rectangle should have to retain it. Note that I am using the commonly used values for the arguments here. Now, if the length of faces is 0, which means no face has been detected from the current frame, then we would execute the continue statement. We would also increment the number of frames. Then we would draw a rectangle around each face. For this, for every face in faces, we would take the top, left, bottom and right of every face and then draw a rectangle around it. The arguments for it signify that the rectangle is drawn from the top left corner of the face to the bottom right corner of the face. This argument denotes the color of the rectangle that we are drawing, and 1 is the size of the rectangle. Now what we would do is, for every face in faces, we would take out the face section, which means the section that contains a face. For this, we define the coordinates of the face section that we want, and then we resize the face section as per our requirements. Here I have used 100 by 100 to resize it. After that, I use the IamWrite function of OpenCV to write the current face to a local folder and then save it as a JPG image. For that, I provide the folder where I want to store it. So I have provided the folder above in the code. This is the folder. And then I provide the frame number to store it, and I store the face section at that location. Then our face recognition library comes into play. we load the image, the JPG image that we had just saved using the load image file function of the face recognition library. In the arguments, we give it the path that we want. Then we convert the face section that is saved into a face encoding using the face encodings function of the face recognition library. After that, we check if the length of face list is 0. Note that face list was a list to store the face encodings of every face. Hence, if the length of face list is 0, then that means that no person has entered in the day. So, we append the face encoding to face list. Or what we do is, we use a compare function to check if the current face already exists in face list or not, which means that the person entering the room has already entered in the same day or not. And if that compare function returns false, then that means that the person has not entered in that day, and then we would append it. So now let's have a look at this compare function. So here we have the compare function, which takes the face list as an argument, face encoding, and the number of frames. It iterates through every element in face list and checks if the current face matches any item in face list. For this, we use the compare faces function of face recognition library. This returns a list, comparison list, which is a list of true-false values corresponding to every face. It gives the value true if the face already exists in face list. For the arguments, we use tolerance to indicate how much difference we can allow between two faces to consider it to be a match. So we do not want the value of tolerance to be too high or too low. So I have set this to 0.5, but you can experiment with it to see what works best for you. After that, for every element in this comparison list, if any element is true, then that means that a matching face has been found. So we would return true. And if none of this returns true, then we would return false. So now that this is complete, we append the face encoding to the face list if the length of face list is 0 or if compare function returns false. After that, we can use the IMShow function of OpenCV to see the faces with the rectangle drawn in them. This takes the argument face section since we are displaying the face section, and then we use this to indicate that if Q is pressed, then we would quit and we would break out of our while loop. In the end, we can print the number of frames and the length of face list, which would indicate the number of people that have entered the room. In the end, we use the release function to close all the IO devices and destroy all windows function to destroy all the windows that we might have created. So now that our code is ready, let's run this. As you can see, my face is being detected and it has been appended. Now if I press the Q key, then I would break out of the while loop and the number of frames has been printed and the number of faces has been printed as well. Since my face has been appended to face list, it would not be counted again if I enter the room on the very same day. Apart from that, if another person enters the room, then the number of faces would be incremented. So this is how our code works. You could use the count variable to store the count of people entering the room in a database for every day. And I guess that's all about the code. Now let's look at some of the common pitfalls that we might face during this project. The first pitfall would be identifying the correct library for implementing face recognition and comparison of facial features. For this, I have used the face recognition library, but you can also feel free to explore any other library that you want. Another pitfall was figuring out the appropriate method for conversion of detected face into face encodings. As you saw, for this, the face recognition library has a face encoding function which can be used to convert the detected face into face encoding. So in the end, these are some of the resources that I consulted for the project. The links for the same would be provided in the description below, and also the link for the code would be provided in the description. Thanks a lot for watching. I hope you enjoyed the video and stay tuned for the next one.